Hello everyone, welcome back to iThinkData. This is Vaibhav and I am thrilled to have you back here. Today we are diving into part A of case study number 2 of Danny Ma's the famous 8-week SQL challenge. If you have been following along, you know we have already tackled the case study number 1 where we broke down each question, worked through the queries and explored the solution in and using MySQL. But this time we are taking on something a little different and equally exciting with the Pizza Runner challenge. Before we jump in, let me give you a quick outline of what's coming up in this video series. Okay, study number 2, that is Pizza Runner, presents us with a unique SQL challenge focused on managing and analyzing data for a pizza delivery service. For this case study, I'll be walking you through 4 parts, that is part A, B, C and part D. Today's focus is entirely on part A, where we'll set up our foundation by exploring some initial data, solving some questions by using the MySQL. So let's talk about the pizza runner. Imagine a startup focused on delivering pizzas as fast as possible, optimizing each part of the delivery process from the moment a customer places an order till the time the pizza reaches their door. Dynama has created this case study to test our skills in SQL by simulating a real-world database scenario you'd find in a fast-paced food delivery service. It's a perfect way to get hands-on experience with the most commonly used SQL operations and develop a deeper understanding of the data manipulation and analysis. Before starting with the case study, let me walk you through the website of 8weeksqlchallenge.com. So now I am on this 8weeksqlchallenge.com website and I have opened this case study number 2 as the pizza runner. So here you can see the introduction here. Then we have the, six or seven tables available. So the table first is the runners table, which has runner ID and the registration date as the columns. Then the customer orders has multiple columns with the order ID, customer ID, pizza ID, then exclusions, extras and the order time. So if you see this table properly, you can see in this exclusion and the extras column there is some mismatch in the data types. Here this 4 is an integer but this null is a string value actually. So after that we need to clear this data. Okay, table third is the runner orders. It includes the columns as order ID, runner ID, pickup time, distance, duration and the cancellations. Here also for same distance and the duration there is some mismatch in the data types. So here you can see like this 23.4 is a float, then 10 is integer, this is null string and here it is a mixed type. So what we will do is we need to clarify this data later on. Then table fourth one is the pizza names. So as of now we have only two columns here, pizza ID and the pizza name. Then the pizza recipes, it has two columns, pizza ID and the toppings. Also table number 6 is the pizza toppings where it has columns of pizza toppings ID and the toppings name. To create these tables into your local machine, the Danny has provided us with the entire schema queries. So you can just copy this all the query and just paste into your local machine and run one by one to create the tables and insert values into it. Okay, so now let's move towards the case study question. So Danny has given us lots of questions here. So he broken down these questions into different areas like this pizza matrix, runner and customer experience, ingredient optimization, pricing and ratings, and some bonus DML challenges. We have divided all these topics into different questions. For pizza matrix, we have given the 10 questions, and our today's video will be focused fully on these 10 questions only. So in the coming videos, I will be discussing these part B, part C, and other continuing parts. To create the database and the tables and inserting values into it, you can just copy all these queries, or what you can do is you can go to my GitHub page here, then click on this 8-week SQL challenge. Then you will go to the main repository here, 8-week SQL challenge. There you will find these multiple folders for different case studies in the Danny's 8-week challenge. So today we are doing the case study number 2. So click on this folder. So there it will open the different files here. And with this introduction, so for the database creation queries, open this file, database creation queries. So you can see all these database creation, then table creation and value insertion queries. So I have written all here. It is just copied from this Danny's website, and I have pasted it here. So what you can do is you can just copy all these and paste it in your MySQL server. So for all my solutions, I am using MySQL only. Also, to create the entity relationship diagram, I have modified the tables little bit to make the relationship between them. Also, to avoid the mismatch between the data sets which I have already shown in the customer order table. So for that table, I have created a temporary table removing all those mismatch to clean the data. So here is the query for the customer orders table, and same for the runner orders table. There is some mismatch in the data types. All that data is clean by creating the new temporary table here. Before we dive into the first question, let's set up our environment into MySQL. If you are coding along, then make sure you have MySQL installed and ready to go with the Pizza Runner database loaded. You can get these database from this Danny's website, or you can just copy these all the queries from the from 8-week SQL challenge GitHub repository from my account. Okay, so now I am in my SQL workbench where I have copied all the database and table creation queries here. So I will run one by one to create our database now. First we will check if database exists. So it does not exist. Let us create the database, then use it, then create the table runners, insert value to runners, customer orders creation, then value inserting into customer orders table, then create runner orders table, then value insertion into it, then pizza names, values to it, then the pizza recipes table and value insertion into it. Next one is the toppings table and the value insertion into it. So now you can see here I have this pizza runner database and all the 6 tables are created now with customer orders, pizza name, pizza recipe, toppings, runner orders and these runners. To create the relationship between the different tables, what we need is the entity relationship diagram. So to create the entity relationship diagram, what we will do is we will modify the tables and assign some primary and the foreign keys. So let's write it. Yeah, I have already written the relationships here now. So I will modify the runner orders table with the foreign key constraint and connecting it to the runners table. So let me run one by one. For same customer orders also, I am doing it. Okay, so we have successfully created the relationships now. To create the entity relationship diagram, what we will do is we will go to database, then reverse engineer, click on next, here choose the database. For me it is pizza runner now. So next, import total 6 objects and execute. Then next, so he see it says that 6 tables are been added, so finish. So here you can see we have this entity relationship diagram now. So I will just make it a little bit clearer one. So now I have rearranged all the tables, and in this way you can see how our relationship exists between these different tables. So now let's clean the data. Now here in this customer order tables, if you see here in these exclusions and this extras column, the data type mismatch is there. So initially it is having these integers, then it is having the null as a string. This is not null value actually, but it is inputted as a string here. Okay, so same here also, and for extras also, this is null value, and this null is a string here. So, and in the white spaces here it may have some white space or black space here, it is not shown here. So what we will do is we will clean this now and make it as a uniform data. Okay, so for this I have created a temporary table name as customer orders temporary table. So for this I am selecting this order ID, then customer ID, pizza ID. Then to select these exclusions, I am using the case statement. So when exclusions are written as this empty or any or nothing is there, then we will take it as a null value. Then for the next condition, when it is given as the null as the string value, then we will get it as a null. And except these two cases, all other cases it will be as it is. And then for the next, that is the extras column, the same case we are applying for the extras column. So for the order time column, we are converting it to a date time function. So let me run it. Okay, we have successfully done this one. Now same for this runner orders table. Now when you see this runner orders table, there also in this pickup time, if you see some dates are given here in this date time format, and for these null values it is as a text, or you can say as a string. So what we will do is we'll make changes in this column also. Then for the distance, you can see this 20 kilometer, then 20, 13.4, this 10 null. There is a mismatch in this data type, so we need to make it as a integer or a float only. Same applies for this duration column also. And also for cancellation, some values are blank, then some are having the restaurant and this customer cancellation, and some are given as null values. What we will do is, to all these blanks and null values we will make it as null, and for all other, so we will keep this as their specific columns. So okay, so let us create this runner orders temporary table. So from there I am selecting this order ID, then runner ID. And for the pickup time, what I am doing is, when the pickup time is null, then we are casting it as null only. Then if pickup time is not null, then we have some values given here in the pickup time. So what I am doing is, it is initially considered as a string only. So here by using str to date function, I am converting that string to date values. Here is the date format, that is what specified to read that date format from this table itself, and I am casting it as a date time here. Okay, and the column name is pickup time only. Again for the distance column, when the distance is null, then it is null. Or else when the distance, we have seen there are different values like 20 kilometer, some floats, some null values. So I am converting that to a float value by using this regular expression function. So I will just get the float values from this. Similar applies to here, the for the duration column also. And again for the cancellation, if the cancellation is nothing, like if nothing is there, then we will take it as null. And if the cancellation is null string, then in that case we will also replace it with this null value. And else it is same as this existing column as cancellation. We are selecting it from this runner orders as the runner orders temporary table. So let's run it. So you can see at the bottom the temporary table has been successfully created. We can see here that temporary table how it is. Now we can see the entire data is properly cleaned. In the pickup time we have only dates, in distance we have only these distance values, in duration only time values, and cancellation only these two cancellation, others are null only. Okay, so now our data is ready for the analysis. So let's move toward the questions. Okay, so now let's get started with the questions. So today we are dealing with the first part of this case study, that is pizza matrix. So the first question is how many pizzas were ordered. So here what we need to do is we need to count the total orders from this customer orders table. So here you can use either customer orders table or you can use our temporary customer orders table. Any one of the both is fine. So I am using the customer orders table to write this query. Here is the query. So I am counting all these rows from this customer order tables as the total pizza orders. And let us run it. And there we go. You can see the total pizza orders are 14. Well, let's move towards the next question. Okay, so question number 2 is how many unique customer orders were made. So here for this question what we need to do is we need to count the distinct order IDs from this customer order table. So I will write the query here. Here is the query. So I am selecting the distinct order IDs from this customer orders table as the unique customer orders. So let me run it. And there you go, you have these 10 unique customer orders here. So as our answer is 10. Okay, so next question, that is third question, is how many successful orders were delivered by each runner. Okay, so for this what we need is we need the runner ID, and we will count the runner IDs as the total successful orders delivered from this runner orders temporary table. And we are applying the group by on this runner ID. So here is the query for it. So I am selecting this runner ID and counting these order IDs as the total successful orders delivered from this runners order temporary table where the cancellation is null. Why the cancellation is null? Because we don't want any order that is cancelled. So all the successfully delivered orders only gets counted here, and we will group by this runner ID. So let me run it. And there you go. This runner ID as 1, this particular runner has delivered 4 orders, then the runner ID with 2 have delivered 3 orders, and runner ID 3 has delivered 1 successful order. Okay, let's move towards next question. Okay, so the question number 4 is how many of each type of pizza was delivered. Okay, so to solve this question what we need is we need the pizza ID, the pizza name, and the total successfully pizzas delivered. Okay, so let me explain you this question with the help of the entity relationship diagram. So I have here this entity relationship diagram. What we need is we need this pizza ID, then the pizza name, and this orders ID. Or what we need is we need the count of order IDs as the total successful pizzas are delivered. So what we will do is we will join these two tables here, that pizza names and this customer orders. But again we need to join this runners orders table also. Why? Because we are going to apply the condition as this cancellation. This cancellation should be null. Okay, so this simply means that all our orders should be successfully delivered only. So what we will do is we will join this runner orders table, then customer orders, and the pizza names here. Since these two data column, that is customer order and the runner orders, have some mismatch in the data types, so we have created the temporary tables for this. So we will use the temporary tables instead of these direct tables. Okay, so let me write the query now. Okay, so here let me explain the query now. So I am getting this pizza ID from this pizza names table, then pizza name from the same pizza names table, and I am giving them names as pizza ID, pizza name, etc. And I am counting these order IDs, okay, from this customer orders temporary table as the total successful pizzas delivered. And I am joining these three tables as I already explained. I am joining runner orders temporary, then customer orders temporary table, and this pizza names table, and applying the condition as the cancellation is null, and grouping by these pizza ID and the pizza name. So let me run it. And yes, I am here. So the pizza ID 1 and 2, then pizza names meat lover and vegetarian, and successful deliveries are the meat lovers 9 and the vegetarian pizzas have 3 successful deliveries. So let me go to next question. Okay, now question number 5 is how many vegetarian and meat lovers were ordered by each customer? Okay, so for this question, what we need is we need the pizza name, then the customer ID, and we will count this order ID here as what the count of orders by each customer. So for this, let me explain you with the help of ER diagram. Okay, so here what you can see is this is the entity relationship diagram. So here we need this pizza name here. It is in this pizza name column. Then we need the customer ID. It is here for individual customer. We need this customer ID, and we will count these orders as this order count of order ID here. So for this we need to join these two table, that is this customer orders temporary table and this pizza name. Okay, so let me write it now. Let me explain. So I am selecting this pizza name from this pizza names column, then selecting the customer ID from this customer orders column, and I am counting these that is total number of orders from the customer orders temporary table, and I am joining this that is customer orders temporary table with the pizza names on the pizza ID as the column, and grouping by the pizza name and the customer ID, and sort by same. Let me run it. And there we go, we have the output here. So we have meat lovers pizzas here with the customers ID 101, 102 and 103, 104. These have ordered the 2233 the pizzas. Then so similarly this vegetarian pizzas ordered by 101, 102, 3 and 5, everyone have ordered the 11 pizzas only. Okay, so let's move towards the next question. Okay, so question number 6 is what was the maximum number of pizzas delivered in a single order? Okay, so for this what we need is we need this customer ID, then we will need this order ID and this count of the pizza ID as the pizza count. So let me explain with the help of ER diagram here. Okay, what we need is we need this customer ID here in customer orders table, then we need this order ID. Order ID is also in this customer table and the runner orders table. Also we need to count this pizza IDs that is in this customer orders table. So what we need to do is we need to join these two tables, that is customer orders and runner orders. Just don't forget that we have both the tables as the temporary tables created using this clean data. We will use that temporary tables here. Okay, so now I have written this query here now. So from as I explained, I am getting this customer ID, then order ID and count of pizza IDs as this pizza count. And I am joining this customer orders temporary table on the runner orders temporary table and applying the condition that the cancellation is null and grouping by this order ID and customer ID. And at the end I am applying this limit 1. Why limit 1? Since we need this maximum pizzas delivered in this single order. So let me run now, and there you go. So the maximum pizza count is 3. It was there in this order number 4 and it was ordered by the customer 103. Okay, let's move towards next question. Okay, so next question, that is question number 7, is for each customer how many delivered pizzas had at least one change and how many had no changes. Let me explain you the solution for this question with the help of the entity relationship diagram. Here what we need is we need this customer ID which is available here in this customer orders table. Then now to find these pizzas that are at least having one change, what we will do is we have noted the changes that is in exclusions and this extras column. So here we are applying this case and when statement. When this exclusion is not null or the extras is not null, any of these two is not null, then we will take it as one. That means one pizza is changed, and or else we will take it as 0, and we will make the sum of this, and we will use it as the pizza has at least one change. Okay, and now for the pizzas that are not at all changed, what the condition is for this also will same use this case and when statement. When this exclusion is null and the extras is null, make sure both, that is exclusion and extras are null, then we are counting it as the one pizza, or else it is 0. So that one pizza is the pizza that is not changed. So, and we will do the summation of all these ones and zeros. So, and we will make it as pizzas not change. Okay, and since we need this condition as this cancellation is null always, so we will join these two tables. Okay, so let me write the query here. So I have written query here. So here you can see I am getting this customer ID, and now to get the pizzas that has at least one change, what I need is I am using this case statement. Okay, now as already explained, when this exclusions is not null, that means there is something that is changed, or there is the extras column also which is also not null. If any of the condition, that is this exclusions or the extras is not null, then we will count it as 1. That means the pizza has at least one change, or else we will make it as 0. The similar condition applies to this pizzas not changed column also. So where we are doing the summation of all these ones and zeros. When our exclusion is null, okay, and the extras is also null, that means nothing is added in exclusion, nothing is added in extras. So for this case we will count it as 1, or else it is 0. So, and we are doing the summation of these ones and zeros, and making it as the pizzas not changed, and joining the two tables, that is customer orders temporary and this runner orders temporary table, and applying the condition that the cancellation is null, and grouping by the customer ID and order by the same. Okay, so let me run this query now. So there you go. You got the customer ID, then pizzas has at least one change and pizzas not changed at all. So the customer 101 has not changed the pizza, then customer 102 has also not changed anything into the pizza, but customer 103 has changed at least one pizzas. Okay. So it is likewise for this five customers as here. Okay, so let's move towards the next one now. Okay, so next question number 8 is, how many pizzas were delivered that had both exclusions and extras? Okay, to solve this question, what I need is I need this customer ID, and now to get these, that is this count of pizzas with both the changes. So for that I will use this case and when statement. So for that what I will do is I will use the statement that when exclusion is not null and when extras is also not null, then I will make it as 1, or else it is 0, and I am counting it as the count of pizzas with both the changes. Okay, so let me write the query now. So here is the query. So as already explained, I am getting this customer ID, and I am using this case and when statement. I am using this exclusions is not null, that means something is changed. Okay, and conditions simply used here because both of these two conditions should be true. So the extras should be also not null, then I am taking it as 1, or else it is as 0, and I am doing the summation of all these 1 and 0 as the count of pizzas with both the changes, and similarly joining this customer orders table on this runners temporary table, and applying the condition that the cancellation is null, and then grouping by this customer ID and sorting by the same. Oh, let me run, and there you go. So this is the customer ID and the count of pizzas with both of these changes. So only this customer, that is 104, has made changes, that is both has exclusions and has the extras also. Okay, so let's move towards the next question. Okay, so the question number 9 is, what was the total volume of pizzas ordered for each hour of the day? Okay, so to solve this question, what we need is we need the hour of the day, and we'll also need to count the order IDs as the volume of pizza ordered. And all these details are already available in this customer orders temporary table. So let me write the query. So here you can see I am selecting this hour of the day from this order time as by using this hour function. From that I will be getting the hours. Then I am counting the order ID as the total count of orders that are placed in that particular hour, and I am getting these from this customer orders table, and I am grouping by hour of the day. Let me run it, and there we go. These are the hours of the day. Okay, so we have 11th hour, 13, 18, 19, 21, and 23 hours, and the volume of pizzas ordered is 133133 as. So let's move towards next question. Okay, so the question number 10. This is actually the last question of this part, that is pizza matrix. Question is, what was the volume of orders for each day of the week? Okay, so for this what we will need is we need this day name, that is day of the week, and we will count the order IDs as the volume of the pizzas ordered, and all these details are already there in this customer orders table. So let me write the query. Okay, so here I have written this query. From this I am using this day name function to get the name of the day from this order time column as the day of the week, and also I am counting this order IDs as the order count of orders, or you can say the volume of pizzas ordered, and all the details are in customer orders temporary table. So we are using this customer orders temporary table and grouping by the day of the week, and order by the pizza orders. It is in this descending order. Let me run, and there you go. You can see the Wednesday has 5 orders, Saturday has 5, Thursday has 3, and the Friday has only 1 order here. So as per the data available, we have these orders here, and you can check that 5 plus 5 plus 3 plus 1, this is 14, and we have total number of orders as 14 only. So it verifies our answers also. So this was the last question from this part A. You can always visit my GitHub account for all the queries that we are solving in this case study. So go to this 8-week SQL challenge, and folder number 2 here. You can find this queries for our part A. So yes, here all these questions and queries I have listed here. And you can simply just copy and paste it in your system. So thank you so much for watching. I really appreciate your support, and I hope you found this video helpful. If you really enjoyed it or learned something new, then please consider liking, sharing, and subscribing to the channel. It really helps out, and you will be the first one to know when the new content drops. Feel free to leave your thoughts, questions, or suggestions in the comments below. I'd love to hear from you. Thanks again, and see you in the next video.